Good day to Dr. Sadikin. So for today, me and my partner, Wan Erni Aida, both of us will be presenting for the final lab, which is lab 7. Okay, so now I'll be sharing the slide for the lab sheet. Sorry, sharing the lab sheet. So this is the lab sheet. Okay, the topic for this lab is system response, frequency response. Okay, as we know, frequency response, another word is bode plot. So basically for this lab, we'll be doing bode plot using approximation based on the objective. Okay, we'll be doing approximation and also actual bode plot, which is using Matlab software. So what is given in this lab is that the transfer function is given, which is gs equals to k over s plus 5, bracket s plus 2 and s plus 50. So these three here, the 2, 5 and 50 is the corner frequency. So we will be plotting the bode plot manually, or also known for approximation, based on these three corner frequency. And for our part, we assumed the k as 1500. So we set the value of gain for k as 1500 and we did some calculations. Okay, so this is our closed loop diagram. Okay, and this is our transfer function with 1500 and the corner frequencies. All right, so this is how we got our value of k, and this is the initial value that we calculated to be used for the bode plot, manual bode plot. So the first one we did was the magnitude plot. Okay, so for the magnitude plot, we used the initial value that we got earlier and we plot, and then the three corner frequency here, which is colored in green, dark blue and also pink, and the yellow here is for the earlier the initial value, and this light blue here will be our final magnitude plot. So this is the corner frequency 2, 5 and 50. So the next one here shows the final magnitude plot that we got using the approximation method. And then the following one will be the phase plot. Okay, so for the phase plot, this is the first line, the 0, the one in red, and then the purple, green and blue. These are for the three corner frequencies, and for the final plot is the one in yellow color. So the next one we showed the final phase plot, which is in yellow color. All right, so this is the final phase plot that we got. So after we got both of these graph, what we did was we used this graph to obtain the value of gain margin and phase margin. So what we did was, from negative 180 on the phase margin, we pulled up towards the graph and we got the value at the magnitude plot for the gain margin, which is which is 20 dB. And for the phase margin, okay, from 0 we got the value on the phase plot, which is 72 degrees. Okay, so this is the value that we got from the approximation. And okay, from that we can calculate the value of k where the system is stable. Okay, so what we did was we did these few calculations to get the value of k, which is k equals to 5000, and we found out that the range of k where the system is stable is from 500 to 5000. So the k will be in between that two values. And then we used Matlab software to do the simulation using the given transfer function and the assumed value of k, which is 1500. So my partner Wan Erni Aida will be sharing a screen to show the result that we obtained from the Matlab software. One.
Okay, thank you, Malini. So I will continue on the Matlab coding. So the numerator and denominator we put from the original transfer function that we got, that we already given, GS, and then I will run it. So in the command window, we need to type our gain. So our gain K is 1500. So this is the bode plot that we get from the Matlab. So this the MATLAB will automatically show the gain margin where it give 22.5 and the frequency at 19 for magnitude, and for the phase margin we got is 71.3 at frequency 4.15. So from the command window, we also can find it also shows the result here. And that's all for MATLAB. I pass it back to Malini.
Okay, thank you, Wan. So as the closure, I would like to share the comparison that we got from the MATLAB and also from the approximation. So this is the parameters which we need to measure in this lab session, which is the gain margin, phase margin, and also the stability. Okay, where the k is in between the range. Okay, using the approximation method, the gain margin that we got was 20 dB, and the phase margin that we got was 72 degree, and then it's stable. And then for MATLAB simulation, we got gain margin as 22.5 dB, and for the phase margin 71.3 degree, which means we can see there's a slight difference in the value, which is totally normal. So I I believe that we achieved the objective of the lab successfully, although we faced some errors and difficulties at the starting part, and we managed to troubleshoot the problems. So I think that's all from me and my partner, Wan and Aida. Wan,
That's
do
all
you have
from us.
anything to add?
Nothing. That's all.
All right, thank you.
Thank you.